Hello everyone, in this video I want to talk about how we can transform some radical functions. So transformations, they are sometimes a headache to go through and to apply and to be able to recognize, but hopefully you've been able to see these transformations for a number of different functions already. So hopefully you've seen transformations of linear functions, quadratic functions, exponential functions, right? So hopefully you're noticing a little bit of a pattern that these transformations look the same, no matter what parent function or what family of functions we're applying them to. So in this video, we just happen to be applying transformations to radical functions, but all the transformations that we're going to go over are the same transformations that we've been looking at through the videos that I've made, whether it's linear functions or quadratic or exponential functions, okay? So in white at the top of the screen, we see horizontal translation. And it's going to tell us what that's going to do. It's going to shift our graph left or right. And it also gives us our notation. So we see f of x minus h. So this part right here tells me that essentially h is my variable that represents a horizontal translation. But we have to be careful here because notice that there is a negative sign or subtraction with that notation, right? It's already there. And so now if I say, okay, let's let h be -3. Well, if h is -3, that's going to become x minus -3, which becomes x plus 3, right? So when I look at that, I say, oh, okay, plus 3, I must be going right because that's a positive 3. But really, it's actually shifting left. And why is it shifting left? Because the number for h was initially a negative number, right? So that with horizontal, it's just kind of opposite of what it looks like. So once again, if h is a positive number, like 7, then we would plug that in and it would look like x minus 7, which we might be thinking left, but we are actually going right. And why is that? Once again, because the number for h was actually a positive number, okay? Now, vertical translation, we're going to shift up and down, and we have f of x plus k. And this one is what it looks like because we have addition, and the variable k represents our vertical translation. So if k is 5, it's going to look like plus 5, and we're going to go up. If k is -6, it's going to look like -6, and we're going to go down. So vertical, a lot easier to deal with than horizontal. All right, now we talk about some reflections. So we could reflect over the x-axis or the y-axis, and our notation, basically the only difference is where this negative sign is located. So if the negative is inside with x, that's going to be a y-axis reflection. Basically, whatever we're making opposite x, we're going to reflect over the opposite axis, the y-axis. Okay, so here our negative sign is outside, or it's making f of x opposite. And remember, f of x is basically the same thing as y. It's our output value. So in this case, we'd have an x-axis reflection, okay? Now in blue, we're talking about horizontal stretch and shrink. So here we're going to deal with a graph stretching away or shrinking towards the y-axis, kind of like this kind of movement. And here we have the variable a, which denotes that, okay? And so notice down here, we also see an a, but the difference between horizontal and vertical is the placement of a, right? So if a is inside with x, we're multiplying x, we are affecting x. That'd be a horizontal stretch or shrink. And notice here, we're actually stretching or shrinking by a factor of 1 over a. And so once again, just like horizontal translations, horizontal stretches and shrinks end up looking opposite of what we would initially think. So if I see this square root of 2x, I might think, oh, okay, that's a 2, must be a stretch. Well, remember, it's actually by a factor of 1 over a, and a is 2, so 1 over 2, so it's actually a shrink by a factor of 1/2. Similarly, if I see 1/3 x, we might think, okay, small fraction, must be a shrink, but remember, horizontal is opposite of what it looks like, so it's 1 over 1/3, which actually becomes 3, and that makes it a stretch. So just like horizontal translations, be careful with horizontal stretches and shrinks. Now, vertical stretch and shrink, once again, just like a vertical translation, is what it looks like. It's nice and easy. So it stretches away from or shrinks towards the x-axis, and that's when a is on the outside. We're multiplying f of x, or our output. So here, if a was 8, we would say that's a stretch by a factor of 8. If a is 1/6, we'd say that's a shrink by a factor of 1/6, okay? So that's how we can read what's happening with our transformations. And so we're gonna look at two examples where we describe the transformation that's taking place, and then we're gonna actually graph it. Okay, so for number one, we have f of x equals the square root of x, so that's our parent function, and g of x equals the square root of x plus 2 minus 3. So I noticed this plus 2 right here. So this is a horizontal translation, and it says plus 2. Remember, horizontal is opposite of what we think, so we're actually going left 2. Now we see this -3 out here, or this -3. That's going to be a vertical translation, and it is what it looks like. So minus, we are going to go down 3. Okay, so you might be asking yourself, left 2 from where? Down 3 from where? Well, it's from our parent function, right? That's what we see right here, f of x equals the square root of x. So if we graph that, we know that is 0, 0, 1, 1, and 4, 2, right? Those are our 3 points that we can see from our parent function, so that's the square root of x. So now for our g of x function, we're just going to take those 3 points and we're going to move them left 2 and down 3. So 1, 2, 1, 2, 3. Okay, 1, 2, 1, 2, 3. And 1, 2, 1, 2, 3. So now my graph looks like this. Okay, so now this would be square root of x plus 2 minus 3. All right, and so now we can think, okay, my domain and range has been adjusted, right? So if we go back and we write down our domain, so now our domain is x values, right? Well, this is going to be anything greater than or equal to negative 2 because we moved left 2. And our range is going to be anything greater than or equal to negative 3. Why? Because we moved down 3. Okay? All right. Number 2, we have f of x equals the cube root of x. So there's our parent cube root function. And g of x equals negative cube root of 2x. Okay? So let's look at our transformations here. We see this 2 right here. So now I know that is a horizontal stretch or shrink. It's opposite of what we think, so it's a shrink. Okay? By a factor of 1 over 2. Okay, so that's kind of the first thing that's happening. Now this negative right here tells me is a reflection. So we have a reflection over, and it's not happening to x, it's outside of that, so it's over the x-axis, okay? So once again, what are we shrinking? What are we reflecting? The parent function, so let's graph that first. So parent cube root is 0, 0, 1, 1, negative 1, negative 1, and we kind of have this pattern right here, okay? All right, something similar to that. So we're going to take those 3 points, and we're going to shrink them by a factor of 1/2. Okay, so if we zoom in here, horizontal shrink by a factor of 1/2. So I know that this point right here and this point right here, they have an x value of 1 and negative 1. So if I shrink them by 1/2, they're just going to move to 1/2. So it's going to be right here and right there. Okay, my point at the origin is still going to stay there because 0 times 1/2 is still 0. So now essentially we're just shrinking this closer to the x-axis, okay, excuse me, y-axis, shrinking it closer there. All right, now we're going to reflect over the x-axis, okay, so now we're going to take these points and let's go with this like pink color here. So this point right here, we're going to move down to right there, and this point right here, we're going to move up to right here. But once again, our point at the origin is still going to stay there, so now we end up with this looking graph right here, okay? And so we can continue this going this way, and going that way. Okay, so now we zoom out and we see what our graph would look like. Okay, and so that's how we can transform some radical functions.